Hello, everyone. Today's presentation is on what is virtual memory. Today, we'll be going over an introduction of virtual memory, how virtual memory works, pros and cons of virtual memory, and some real-world examples and tips. So, the introduction to virtual memory. So, what is virtual memory? Virtual memory is a system that uses part of your hard drive to act like RAM. It allows your computer to run more programs than it could with physical memory alone. This helps manage resources and keeps your system stable. Virtual memory is controlled by the operating system, and it extends RAM using disk space, allows multitasking, prevents program crashes, and managed automatically by the operating system or the OS. So why do we need virtual memory? Computers often don't have enough RAM for every task. Virtual memory fills in when RAM runs out. This way, programs don't have to stop or crash. It gives the illusion of more memory than the computer physically has. This makes running big programs possible. This helps with multiple open applications, keeps performance stable, and improves memory flexibility. So, some key terms to know. To understand virtual memory, you need to know a few terms. These include RAM, a hard drive or SSD, page and page fault. RAM is fast memory. The hard drive is slower but holds more data. A page fault happens when data isn't found in RAM and must be loaded from disk. So RAM is fast memory, hard drive is backup memory, a page is a memory block, and a page fault is data loading from disk. So how virtual memory works. It uses page and page tables. Programs are broken into small chunks called pages. The computer keeps a list of where each page is. This is called a page table. Pages are moved from RAM only when needed. This helps save space and speeds up the system. So pages are small memory sections. The page table keeps tracks of all these pages, and these help save RAM space and speeds up memory usage. So address translation. Virtual addresses are used by programs and translated into physical addresses by the MMU, or the Memory Management Unit. This lets programs think that they have all the memory they want. The system handles the translation quickly and quietly. It keeps everything running smoothly. Virtual does not equal physical address. MMU does the conversion. This keeps programs isolated and enables safe multitasking. So page faults and disk access. If a program needs a page not in RAM, the system loads it from the hard drive. This delay is called a page fault. Too many page faults can slow the system down. The goal is to keep important pages in RAM as much as possible. Page fault is equal to causes a delay, and it causes disk access, it slows performance, and the operating system tries to avoid too many page faults. So we're moving on to pros and cons of virtual memory. So the benefits of virtual memory. Virtual memory makes the computer more efficient. It allows you to run large applications and many tasks at once. It improves system stability and protects programs from interfering with each other. All this happens behind the scenes. So you're able to run more apps. It protects program memory, reduces crashes, and increases multitasking. Some drawbacks and thrashing. Using too much virtual memory can cause thrashing. This happens when the system spends too much time moving data between RAM and the hard drive. It slows everything down. It's a sign that the system needs more RAM. Thrashing is a performance drop. This is caused by too many page swaps, too much virtual memory use, and you may need a RAM upgrade. So, balancing RAM and virtual memory. To avoid problems, the system needs a good balance between RAM and virtual memory. More RAM means fewer page faults. and less reliance on the hard drive. Users can adjust the virtual memory settings in some systems, but the OS tries to manage this balance automatically. More RAM is, means better speed. Virtual memory is backup. It can be adjusted in settings, and the operating system manages most of it. So, some real-world examples and tips. Well, operating systems that use virtual memory. All modern systems use virtual memory. This includes Windows, Mac OS, Linux, and Android. They all use paging and other techniques to manage memory. Users rarely have to deal with it directly. So Windows, Mac, Linux, Android all use virtual memory. Paging is common and is invisible to most users. When you see an action, you might notice virtual memory when your system slows down or your hard drive becomes noisy. This usually means it's handling lots of page faults. It happens when you open many browser tabs or large applications. The system is working hard to keep everything running. Slower system means more virtual memory use. Many tabs or apps equals high memory use. And disk activity is page swapping, and these are signs of memory overload. Tips to improve performance is to reduce virtual memory usage, close unused programs. Adding more RAM is the best way to avoid performance drops. Keep your system updated so memory management stays efficient. You can also check settings to optimize performance. Close unused apps, add RAM if needed, update your operating system, or and use performance tools/settings. Here are some resources. Yep. Thanks for listening. If you'd like to learn this lesson with Cyber Seniors Mentor, please go to www.cyberseniors.org or call the number 1-844-217-3057 to register for a one-on-one phone session. We also host weekly tech drop-in sessions from 2 to 3 p.m. Eastern Time on Thursdays.